Hi, in this video I want to show you how to set up the field of view component within a small game. Field of view itself can be used for any type of games, like shooters, tactic games, strategies, whatever. It is all limited only by the idea. For the current demonstration, I choose stealth genre. As a prerequisite, I've built a small level. It looks like a tiny part of a maze, and the main goal for the player here is very simple. He has to escape from the maze without being detected. Basically, he has to reach the green circle at the end of the level. To reach it, the player has to avoid two types of enemies: video cameras and guards. Luckily, there is only one guard here. At the moment, there is no detection logic present in the game, so we can simply reach the end of the level. Obviously, it is not what we want. Instead, we want to challenge the player, but still make it possible to win the game. Let's start with adding the field of view component to all enemies on the level. This can be done in bulk mode, when the set of field of view owners is selected, or one by one. Bulk mode gives a benefit of having shared material for all field of view instances created at the same time. Here I want to emphasize that the material only is shared. The configuration itself is always per object. Let's add the component in bulk mode for all the cameras and also personally for the guard. For each holder of the field of view, we have to create an empty game object first. It is a requirement for better isolation of characters' components. Now the assignment can be done via simple drag and drop. We don't need to persist material, so I just cancel this window. Default configuration must be adapted. Again, it can be done in bulk mode. Let's start with cameras. As for the radius, we have to give a possibility to player to hide in corners, so let's make it 0.75. The rest of general options seems okay. Now visibility. Let's leave it default, means always visible. Now rotation patterns. Cameras do not change the behavior in case of detection or cooldown, so let's make both patterns equal to linear. Now we have to set targets layer. But we also have to put our player into this layer. There are no semi-transparent objects on the scene, so transparency configuration can remain as is, by the way, as well as other settings. Now let's apply similar settings to the guard. Radius can be 1. Other general settings, as well as visibility, can remain default. But as for the rotation patterns, we can make them more realistic. Slow wave for the default rotation will fit perfectly, as well as fast wave for the cooldown. Targets configuration must be equal to targets, and the rest can remain default. At this moment we can already try to play and check the result. Seems the configuration is quite okay. The only remaining part we have at the moment is handling of the feedback from the field of view component. The game doesn't take into account the fact that the player was spotted or detected. To make the demo more interesting, we can define some rules for our game. First, if the player is detected by any field of view, then it leads to the game over. Player can be detected by either camera or guard. Second, if the camera spots the player, then the guard is being notified and goes to the place where it happens. Third, if the guard spots the player, then he starts following him and go back if the player is lost. First, let's create an empty game object that will act as a game manager. In addition to it, we need a simple C# script that will subscribe to all fields of view on a scene and will be monitoring them. Let's call it Game State Manager. To access all the fields of view, we need a collection of their owners. By the way, for now we don't need a start method. According to the official documentation, field of view has a set of callbacks for different events. Also, it has a callback for target detection. So let's use it. We need a method that will be subscribed to this event. Let's create one. The signature of the event has one argument: game object, the one that was detected. The body is very simple. First, we freeze the game to highlight that player cannot continue anymore. And second, we write a message about game over to the console. Subscription to the event can be done in on-enable method. At this moment, the first game rule is implemented. Now we have to extend Game Manager so it can recognize that the player has reached the target and win the game. This can we do simply by checking the distance between the player and the target. Let's add a couple of fields for these entities. The behavior can be the same: stop the game and write a message. First we have to set the player and the target. Now we can try if it works fine. And now let's check if we can win. Yes, it looks fine. The next part is a hint given by the camera to the guard whenever the target has been spotted. The way how we will do this is very similar to what we have already done. We have to subscribe the guard to the events from the cameras. First, let's introduce the collection of cameras. Now let's link them via inspector. And now we can add the remaining logic. We need a method that will be subscribed to the proper event. And we have to subscribe in a proper place. Let's check if it works. Yep, it works. The last rule we have to implement is a logic for the guard to follow the player being spotted. To do this, we need an access to the field of view script. Let's add a field for it and implement init code. The algorithm is very simple. Inside the update method, we can poll the position of the target, if it's visible, and continuously update the direction for the guard. For the next attempt, we can disable cameras. It will give us more convenience for the testing. Seems now we can try the whole game. Cool, it works as expected. Detailed documentation of all the available properties and API can be found inside the asset in the Documents folder or online via link in the description of the asset, as well as this video, and of course via small help icon on the component. Small remark regarding the component itself. As you see, it is implemented in quite unusual way. Very often field of view is represented as a texture on the ground, but my component gives a 3D model of the field of view. And from my point, it's rather a benefit than a weakness, because it allows to control the direction the player is looking now. I've done a small improvement to the level to prove this. Please check it out. First camera is quite easy. As well as the second one. But at this moment I cannot move, because the third camera blocks my way, and the guard will come soon. Let's use some distraction to pose the guard. At this moment the field of view is pointed to the floor, so its size is reduced, and the player can come out from the hiding place. And now the way is free. I hope now you're convinced. Thank you for watching, and feel free to contact me in case of any questions, feedbacks or suggestions.